Sometimes when we work with forces, we find the force is not parallel to or perpendicular to the principal axis. If we're going to add it to other forces, we need to find that part of the force which is parallel to the axis, that part of the force which is perpendicular to the principal axis, so we can add them to the other forces. It just makes life a lot easier. The way to do that is we treat the original force as the hypotenuse of a right triangle. Then the component forces are going to be the other two sides of the right triangle. We're going to take one part of the right triangle, the horizontal portion relative to the principal axis. That becomes our parallel component of our 12 Newton force. We're going to take the other side of the right triangle, opposite of our angle. That becomes the perpendicular component of our 12 Newton force. To find the value of the parallel component, we're going to take our 12 Newton force, multiply it by the trig function of the cosine of our 60-degree angle, and then we end up with a parallel component of our 12 Newton force being 6 newtons. We're going to do a similar process with the perpendicular component of our 12 Newton force. So our perpendicular component is going to be, again, our 12 Newton force times the sine function this time, since it's opposite 60 degrees. So our perpendicular component of this force is 10.4 newtons. It doesn't matter which quadrant our force is in, we're going to work with angles between 0 and 90 degrees, and we're going to again use the hypotenuse as our 25 Newton force. The two other sides of the triangle are components parallel to the surface, perpendicular to the surface. Parallel component, this time we're going to take 25 newtons, multiply it by the sine of the angle because our parallel component is opposite the angle this time. So our parallel component of our force is 12.5 newtons. For the perpendicular component, we're again going to use our 25 Newton force, multiply it by the cosine of our 30-degree angle. So we end up with 21.7 newtons as the perpendicular component of our 25 Newton force. Yet a third quadrant. This time again our angles between the horizontal and our vector, our force vector of 15 newtons. The angle can be between the force vector and the horizontal. It can be between the force vector and the vertical. We do the same process. So we put in our vertical or perpendicular components, put in our horizontal component, and now we'll calculate the values. Perpendicular component, take the 15 Newton force, multiply it by the sine of the angle because this side is opposite our 20-degree angle. So our perpendicular component this time is 5.1 newtons. Parallel component of our force, again, 15 newtons. We're going to take it times the cosine of 20 degrees this time, and so our parallel component is 14.1 newtons. So that's how we break forces apart into their components parallel to and perpendicular to the principal axis. So we can add these vectors parallel to each other and find net forces or vector sums more easily.